Hello. So I'm Jeff. I'm from Chef Software. I've been at Chef for about 2 years. I'm a senior solutions architect. I came to Chef with about 6 years Chef experience. I work with a lot of customers historically with what you might know of Chef as your infrastructure or config management tools. What most people don't know is that we also operate in the compliance space, specifically around compliance validation plus remediation in a continuous pipeline. So I'm going to be talking about DevOps versus DevSecOps. You're going to also hear what some of the standards are that I encounter with my customers. Also talk about exceptions, specifically around how people are doing audits today and why exceptions are always necessary but not often implemented correctly. And then I'll get into a demo of our patterns around continuous compliance as code instead of traditional methods, which usually involve spreadsheets and other awful things like that. And if there's time, we'll do Q&A. Otherwise, I'll hang out after the event or after the talk. And then we have a booth just right over there. So first of all, DevOps versus DevSecOps. I mean, everybody's heard of DevSecOps. I think it's important to be considerate of that term. DevOps has been around, obviously, a long time. My understanding, the way I like to think of DevOps, is it just recognizes this relationship between developers and operations people being involved in the change lifecycle of application code. Think of any Java app, probably needs a Java runtime, and that's not often managed by the application, so developers and operations people have to work together. Well, DevSecOps just recognizes that more and more security compliance is a required part of our change management process. And so DevSecOps recognizes that we should be able to apply some of the same practices using pipelines, using automated testing frameworks, using automation to test compliance in combination with the rest of our change management. And there's Dev, Legal, Sec, Net, QA, GovOps, if we want to be super accurate about it. Some of the standards, you've got the two main, CIS and DISA, as well as DevSec and FINRA. So CIS and DISA are what I encounter probably 90% of my career. Most of the Fortune 500 is using CIS. Most of federal space and government are using DISA. DISA is kind of a mil spec, and then CIS is just general compliance standards. Now, you've heard of PCI and SOX and HIPAA. Those cover more than just configuration. So those don't cover on VM, or those don't 100% just cover on VM config or cloud config. Those standards define how workflows should, how you can better use workflows and how you can better use, or how you should be doing compliance around your paperwork and things like that. So standards from CIS and DISA make their way into PCI and SOX and HIPAA. So I'll be focused on the CIS and DISA portions. So even in 2017, with the enormous spending that we have in time and money, we're still seeing large-scale attacks growing by almost 30% annually. That number's actually going up. And a lot of people often think that 0 days are what we really are people are targeting, and that's where we're seeing these massive intrusions and data theft. But if I were to kind of poll my customers, I might poll the audience, how many of people in this room are actually using or working in environments with compliance and patch levels that are severely... Don't raise your hands. No, that's bad. So I know that most people would not admit to that in public, but you're not sitting here if you're not trying to figure out a better way to deal with compliance and patch management. So CIS is what I'll cover for this talk and a little bit of demo. It's the Center for Internet Security, and they release benchmarks, usually levels 1 and 2 of most of the modern operating systems, and they release either monthly or quarterly, depending on how much has changed in that operating system. So if you go to their website, you can read these benchmarks for free, and they'll even give you some directions to actually testing on your servers themselves. They'll give you, some simple commands that you could run or where to look to see if you're configured correctly. However, if you pay CIS, they will give you SCAPs. And these are XML documents that are essentially what you get on the website, but intended to be consumed via some form of automation. Now, usually the automation is going to be for reporting and not so much applied to servers to give you some actual report of how compliant you are. So enter tools like Inspec. So Chef, the company, acquired the Inspec project a while ago. I think it was like 4 or 5 years ago. And the language is a mix of actual compliance rules. So this rule at the bottom, lines 109 to 111, are the actual Inspec code that says, hey, on that Windows system, inspect the inspect the security policy, look for what the value is of password history size, and fail the test if it is less than 24. And all of the other data, that's just metadata that assists in the reporting that you end up getting once you run these types of reports. So Inspec is a language anybody can write controls for. It supports Linux and Windows. And then if you're a Chef customer, you get access to all of CIS and all of DISA in the format of Inspec, which allows you to actually run these tests not only in production environments, but non-production environments and pipelines and local dev. So, and I'm going to talk about why that's important. This was my slide kind of demonstrating that we have these profiles available. So why is this important? Because anything we do that relates to our servers, any change we make, even involving the changes of how we test and validate those servers, that needs to be represented in code, or it should be, because we get to take advantage of code development practices where we've got peer reviews and pull requests, which are an automatic audit history of all changes. You can use automated pipelines to control who can deliver change, based on approver workflows and things like that. And so even exceptions, there's a common joke in compliance, which is, if you perfectly secured a system to CIS and DISA, it would be a great boat anchor and about, useless for anything else. And if you don't believe me, try setting no-exec on /temp. You'll find very quickly that your package managers, for one, will absolutely not work anymore. So everybody runs exceptions, but the problem is the way that they are managed. So, how many people have asked for a 90-day exception? And then how many people have asked for another 90-day exception after that, right? How many people have had a exception that was waived over email and then had to go back to that email and said, see, they told me I could do it, right? That tends to happen. So the problem is we're not interfacing with the security teams the way that development teams and operations teams started to work together, meaning in code. We're still using email, we're still using spreadsheets. So in our opinion, the best approach to your compliance validation should be to put that compliance code, those compliance checks into code and make them accessible to basically anybody that needs to be involved in the change management process. So here would be an example of encoding an exception in code. This would be consumed by a tool like Inspec, and Inspec would skip a specific test, and here's justification, and you could imagine somebody accepting that pull request, and now for all of history, there will be knowledge of who is involved in that choice. Audits, we tend to see people scanning maybe once a year, where they take a subset of servers, and the SCAP scan tools do not, they're not fully able to automate all of the testing, so there's often a lot of engineering time and a lot of manual steps to audits. That's why they're only so often. And often audits are performed internally and then externally, and those auditors will repeat the same process but only on a sample of servers. And then remediation, again, the path to remediation is usually a spreadsheet, and then that maybe ends up in a backlog, and then you end up with that exception flow that I just talked about. So even though we're spending lots of time and money on compliance validation, what we need to be doing is having a better process around how we define that code and how do we actually implement things like exceptions. So sort of here's the better way, and this is what we'd call continuous compliance. So you would create a profile that contains the standards that your organization cares about, and it can be a mix of CIS or DISA or anything else that you might write. It's intended to be executed automatically on every server on some interval with test results recorded and stored, obviously with automated reporting when there's failures. But more importantly, we have the ability now, because it's in code and it's very easy to execute and returns and exit code, that we can put these tests inside your SDLC pipeline for your change, right? And ultimately, what that does is it shifts that remediation cycle left to the developer, and the developer and the people on the DevOps teams are now able to either execute these tests manually to find out if their change is going to break compliance, or if their remediation is going to work, or their pipeline's going to do that for them. But it's going to, more importantly, gate any future change from breaking compliance if this is all implemented correctly. So, this is just kind of a graphic that shows this, and then I'll go through a quick demo of it. But really what we're just telling you is if you can use a testing language that's in code that you can run from anywhere, then you can absolutely use it in every environment from dev to production, which is very different than using, and having a team that just audits production after you've already deployed. And just a little bit of customer evidence around here. Scholastic is a big customer of ours. They use both Chef for config management and Inspec as a validation tool, and so their pipelines are enabled with this, which enabled them to add a remediation for shell shock, test it very rapidly, and actually deploy it to their production environment within an hour. Another one of our big bank customers has actually eliminated $2 million in software and tool chains while reducing remediation time just by implementing these patterns. And it's a really simple pattern. It's just we don't have the right people looking at it from the right angles. So let's see. This is just a little marketing slide. I'm going to skip over it and just go to a demo. So this demo is going to be, and let me just peek at time. Okay, so this demo is going to be about what it would look like from a developer's perspective. Somebody who manages some Chef code today and wants to see what a remediation might look like. So it usually starts where, hang on. And I am hoping, yes, okay. I had no Wi-Fi before I walked up here. So what this usually starts with is, and this is our UI, our dashboard around both Chef client run logs and compliance run logs as well. So this is a dashboard showing me all of my environments. So we've got prod and dev servers. And I can see if I click on any of these that I have a bunch of inspect controls that are running, and one of them is failing. And so this is an example of maybe Telnet server is installed and it shouldn't be installed. So we already know production's broken. As a developer, often what people will do is they will write a fix and they'll deploy it and they'll hope for the best. But we can actually do better than that. I can go to my code and I can use a tool called Test Kitchen. And Test Kitchen works with any config management tool and any testing tool. By default, it works with Chef and Inspec. But you could definitely, if you're an Ansible or a Puppet Shop, you could use Test Kitchen to spin up VMs, run your config management code, and then execute your inspect code. And this is a result of running Kitchen Verify on a VM that I pre-warmed. And what you're seeing here is a failure that matches what I saw in production. So now, as a developer, I can go to my code and find in my code where I'm installing Telnet server and add a remove. And when I run kitchen converge, it takes that same VM that's already running. And obviously in a pipeline, you wouldn't keep a VM running. We have a command that'll spin it up, run your Chef code, then run your inspect code and give you an exit value. In this case, I had it running for my demo. But that's Chef running, doing the remediation, And then when I rerun kitchen verify, it's going to rerun that inspect code that was in production, and I'm going to know for sure that when I ship this code to production, it's going to end up with full successful controls and 0 failures. And this is something that you would do on a developer workstation, but also on a pipeline as well. And that's how you can ensure that any change flowing through your systems is not going to break compliance because you've got continuous compliance validation. So being that this is only 20 minutes, that's as much as I can show you demo and slideware. Leave our logo up. And oh yeah, reminder to complete the session survey. And I don't know if I've got time for questions. Yes, I do. I'm getting a head nod. If anybody has questions, holler. And I guess we got a mic.
Yeah, let me bring a microphone so that way you can be heard. Just raise your hand. Questions? Okay.
Yeah, the challenge is some of them non-compliance. You have to risk rate them because they're not all the same. So how do you get risk rating for some of the non-compliance ones, right? Did you get the question? No?
So you said the markup lines, we have to restrict some of them.
No. So the non-compliance has to be risk rated.
Yep.
Because not all non-compliance is the same level of risk.
Oh,
right?
yes.
So how do you have a mechanism to risk rate them as high, critical,
yes.
medium? How does that work?
Yeah, if you see the code example that I gave you earlier, you'll see on here, if that shows up, this impact is a scoring system. And so this will route your controls into low, medium, or high risk. And that allows you to triage basically what's important first. And these come right from CIS, but if you wrote your own controls, you could assign your own risk.
Anybody else?
Any other questions?
Going once, going twice. We're
Okay.
good.
Thanks.